Okay, an object is heated in an oven until it reaches X degrees. Okay, so it is then allowed to cool, and the temperature heater is after this is here by following up. Okay, so it's 20 plus 100 multiplied by 0.8 to the power of T over 6. Okay, so the first one, until is allowed to reach X. Okay, or is allowed to reach X. So how do we go about doing this? Is that when you see, okay, it's heated in the oven until it reaches X. It is then allowed to cool. So the time starts okay, when the temperature after it has cooled for T minutes. That means what I'm trying to say is T has started the time. This T basically commences when the object starts cooling. Okay, so at the point where the object is cooling, right, at the point where the object just started cooling, is actually at X degrees. Okay, so at the point where I'm about to start cooling, where I'm going to start my cooling process, right, the temperature is actually X degrees. And what was the time? The time has started from there. So I mean, the time actually will be equals to 0. Okay, can. So basically, right, what we want to do is we take our theta equation. We know that the cooling follow this formula equation here, 0.8 to the power of T over 6. So if we were to substitute 0 in, sub 0 inside, okay, this will give us, if we sort of sub, say T equals to 0, theta will be equals to 20 plus 100, 0.8 to the power of 0 over 6. And this will just give us 1. I mean, anything to the power, I mean, a to the power of 0 always be 1. So this will be equals to 20 plus 100, which gives us 120. So X is actually equals to 120 because X, which is theta, when your time is 0. When you start cooling, the temperature of the object is actually X degree. That's where your time has just started equals to 0. Okay, so this is part 1. Okay, so just write down here, it's equals to 120. So next one, let me just go to part 2. What is the value of theta when T equals to 8? I think this is quite straightforward. I mean, for when T equals to 8, all you need to do is just sub T equals to 8. So following the formula 20, theta equals to 20 plus 100, 0.8. T equals to 8, also 8 over 6, right? And this should give you approximately about 94.3. So it's 94.3. All right. I will not go through part 3. Sorry, do I go to part 3? Oh, yes, I should go to part 3. Yeah. What's the value of T where theta is equals to 84? So part 3 here, instead of asking you to find theta, they ask you to find T. So theta is 84. We put our theta as 84. This is 20 plus 100, 0.8 to the power of T over 6. So the objective here is to find our value of T. All right, bring over my 20, that's 84 minus that's 64, equals to 100, 0.8 to the power of T over 6. All right, and I divide 100 over, that gives me 0.64, equals to 0.8 to the power of T over 6. Now, it may seem like at this point in time, you might want to use ln. Okay, but of course, in this chapter, by right, it's topic 3. We haven't really used logarithms yet. But just do a quick observation. You can see that 0.8 square is actually equal to 0.64. It's actually 0.8 square. Okay, so comparing the two bases, they are the same. You can see that we straight away can throw away the cut off the base. See, T2 is equal to T over 6, and T is actually equals to 12. So that's for part 3. Okay, and part 4, similar to the earlier questions, right? When T gets very large, okay, this portion here, 0.8, will actually go towards 0. It will actually go towards 0. Okay, so you can actually look at the graph itself, and you know that because you are looking at 0.8 to the power of T over 6. This is like basically 4 over 5 Q6, which is the same as 5 over 4 to the power of negative T over 6. If you were to sketch this graph out, you know that it will go to something like that. You'll go towards 0. So because it goes towards 0, theta as T gets large, well, then 0.8 to the power of t over 6 will become negligible. Okay, it becomes very, very close to 0, or you will say it tends towards 0, it decreases towards 0. Okay, it becomes negligible. And therefore, the value of theta, we can just sub 0.8 to the power of t over 6 and 0. This is equals to 20, or approximately 20 plus 100 multiplied by 0, which will give us, the value 20. So that's what the theta will be when time gets large. Okay.